All right, welcome back again. Let's do an example where we see how this works out in practice. So, let's classify the critical points of the function f that we looked at earlier, which was x cubed minus 9x squared plus 24x minus 10. All right, remember we already had that the derivative was 3 times x minus 2 times x minus 4. So that meant that x equals to 2 and 4 were the critical points. And now the question is, are they local maxes, local mins, or neither? That is, the saddle points. All right, so the trick was to look at the way the derivatives behaved. So 2 was a critical point, 4 was a critical point, and we care about the sign of the derivative, whether it's positive, meaning the function's going up, or negative, meaning the function's going down. So here's where the derivatives were 0. Now, the function here, remember, is 3 times x minus 2, x minus 4. That's the derivative. Now, to the left of 2 here, x is smaller than 2, so this term is negative. And if x is smaller than 2, it's certainly smaller than 4, so this term will be negative. Together, the whole thing will be positive. In this region, x minus 2, well, x is bigger than 2, so the first term will be positive. But x is less than 4 here, so the second term will be negative. So the whole thing will be negative. And over here, x is bigger than 4, so it's bigger than 2, so x minus 2 is positive. And it's bigger than 4, so x minus 4 is positive, so the whole thing is positive. All right, so that means on the rough sketch of what f looks like, since the derivative is positive here, it's kind of going up. It'll flatten out at the critical point. Now the derivative becomes negative, so it heads down. The derivative is 0 at the critical point, so it flattens out. And then the derivative is positive, so it's going up. So you can see right away that this is going to be a local max, and this one is going to be a local minimum. So, recording that, you have x equals to 2 is a local max, and x equals to 4 is a local minimum. So now we know the behavior of those critical points. Let's do another example. All right. Here we're going to look at the function f of x equals to x cubed. Its derivative is 3x squared. So if we solve f prime of x equals to 0, that means we have to solve 0 equals to 3x squared. So the solution is x equals to 0, and that's the only critical point. Okay, so there's a critical point, and the question is it a local max, minimum, or neither? Namely, a saddle point. All right, well, let's draw our little graph here. This is where x is equal to 0. Let's put the behavior of f prime here, at least in terms of its sign. So the derivative, remember, was 3x squared. Okay, that's the derivative. And x squared is always positive to the left of 0 and positive to the right of 0. So if you do the rough sketch of f, it'll be going up, and then it'll flatten out sort of momentarily at 0, and then it'll still be going up. And so you see this point here is not a local max and not a local minimum, so this is a saddle point. Neither max nor min, so the only critical point, x equals to 0, is a saddle point. And that classifies that critical point. All right. See ya.